Now, let's turn to an astonishing story. The massive volcanic blast last year in Tonga in the Pacific. It was felt 18,000 kilometres away on the other side of the world on the floor of the Atlantic Ocean. It was one of a number of intriguing phenomena picked up by the instrument network set up by scientists in the Azores, Madeira and Canary Islands region. Well, Ana Ferreira is the Professor of Seismology at UCL and the principal investigator of this study. Anna, welcome here to the programme. I mean, firstly, that is absolutely incredible, isn't it? 18,000 kilometres away?
Yes, absolutely. We were really thrilled when we saw these signals. They were quite unexpected, really. So it's absolutely thrilling and not the main purpose at all of our study, which was to record and study earthquakes.
Tell me more then about the unexpected nature.
So this signal particularly is very unexpected because we did record the seismic waves that propagated through the interior of the Earth. That's expected. But then there were these very interesting and very unique waves in the atmosphere following the massive explosion. And we recorded those waves as they then went into the water and then to the seafloor. So 5 kilometers deep into the water on the other side of the Earth from the explosion. So really quite spectacular.
Tell me a little more scientifically what was going on, why a volcano like this could then end up with your instruments picking up activity on the floor of the Atlantic.
Yes, so this was a very unique event because it was a massive explosion. So in our century, it's really the biggest one that we have ever had. Historically, there was the Krakatoa explosion that was somehow similar, but in the 19th century. So with modern instrumentation is the first time that we pick up such a massive explosion. And then the explosion, so a big bang really, so lava coming up from the seafloor, so it was a submarine eruption. It created these massive waves. You can imagine like a massive stone being thrown to a pond that makes this big blast that creates oceans, waves in the atmosphere and also in the solid earth. Those waves in the atmosphere, they traveled all around the earth many times, and they were so powerful. So these were pressure waves that as they passed through above the ocean, they also propagated into the water. And then because our instruments are very sensitive, extremely sensitive in the seafloor, they could pick up these motions at such depths. Yeah.
As you were describing it, we were seeing the pictures of the volcanic blast. I mean, it is extraordinary exactly as you describe it. I mean, is there any sort of way to quantify the energy that was actually released here?
So there have been several studies using other types of data. So we are talking about, it displayed over 10 cubic kilometers of rock, ash and sediment. So that's the sort of size that we are talking about. But we hope that with our data, we can even get further constraints on what happened.
And in terms of those shockwaves that you were describing going through the Earth's crust, I mean, how fast were they moving? How long did it take to get to the other side of the world?
Yes, so the atmospheric waves, they were slow. So they were going at typical sound speeds, so a few 100 meters per second. So they were slow. They came several hours after the actual seismic waves. The seismic waves, they propagated at the typical wave speeds of a few kilometers per second, so faster.
Just a final question then. I mentioned in the introduction that these instruments, they picked up other phenomena as well. Just take me through that. We've got about a minute left on the programme. What else did you find?
Lots and lots of whales singing and chatting with each other. And it was actually fascinating to see the dominant signal of whales really very, very strongly with a seasonal dependency. So appearing very strongly in the winter in particular. This is linked with migration of whales in the region. So this was really fascinating. Lots of ships as well. This region is a highway going from Europe to North America and vice versa. But in particular, also a sinking, exploding ship. So there was a ship full of luxury cars like Lamborghinis and others near the Azores that sank, and we really recorded quite nicely the explosions and the signals of that sinking ship. So whoever wants to venture can go and try to pick them up from the seafloor.
Anna, your enthusiasm is obvious, but I'm going to have to stop you because we've got to take a break. But thank you so much for joining us here on BBC News. Thanks so much for your time.
Thank you.